Hi everyone, it's Christy here back for some more calculus. So in this problem we have a limit, and whenever you see a limit problem, the first thing you should always do is direct substitution. So I'm going to directly substitute in 3 for these values of x. So I would have 3 plus 2 over 3 minus 3, or 5 divided by 0. Okay, so notice in this problem, after direct substitution, I get a non-zero value divided by 0. In this case, if this happens after direct substitution of a rational function, you know there has to be a vertical asymptote at x equals 3. Now, if you had gotten 0 divided by 0 after direct substitution, click here to see this video and how to evaluate a limit problem like that. All right, so we have determined that there is a vertical asymptote at x equals 3 because after direct substitution, we get a non-zero value divided by 0. So what could a function look like if it's approaching a vertical asymptote? Well, in our first example, as it approaches this vertical asymptote in red, the function could approach infinity on the left and infinity on the right. Now in this case, some people say that because this function is not approaching a specific value, this limit does not exist. But I like to say that this limit is infinity in order to provide some more information because the limit from the left and the right are both infinity. Likewise, in this next problem, the function is approaching negative infinity from the left of that vertical asymptote and negative infinity from the right of that vertical asymptote. Some people say this limit does not exist because the function is not approaching a specific y value, but once again, I like to say negative infinity because those limits match up and it gives us more information about what the graph is doing at that vertical asymptote. In this third example, this limit is approaching negative infinity on the left and positive infinity on the right. Now this one, because those limits are not the same from the left and the right, this one I would say the limit does not exist at that vertical asymptote. And likewise on this last one, because the function approaches positive infinity on the left and negative infinity on the right, again, the limit would not exist because those limits are not equal from the left and the right. Okay, I want you to notice an important point. And it directly relates to the fact that we said we know there is a vertical asymptote at x equals 3 on our example. So I want you to notice something. As a function approaches a vertical asymptote from either the left or the right, notice that the only options that the limit can equal are positive infinity or negative infinity. There is no other choice. So I want you to keep that in mind, again, as the function approaches the vertical asymptote from the left or the right, the only options are positive or negative infinity. Now, because here we determined that there is a vertical asymptote at 3, we need to look at this function a little bit more further and specifically look at what's happening on the left hand side of 3 and also on the right hand side of 3. So let's look at the limit as x approaches 3 from the left hand side. Well, once again, we said we absolutely know there's a vertical asymptote at x equals 3 because after direct substitution we got a non-zero value divided by a value of 0. So our only possible options as we approach that vertical asymptote from the left is either positive infinity or negative infinity. Now to do this, I like to think of a number that's just to the left of 3. So I'm going to think of 2.999. That's just to the left of 3. Now if I plug that into the numerator and add 2, I get a positive number. Now I don't care what the number actually is because remember, my only options are positive infinity or negative infinity as I approach that vertical asymptote. If I plug in 2.999 minus 3, I get a negative number. And a positive number divided by a negative number is a negative number. So therefore, x approaching 3 from the left is negative infinity because as I plugged in a number just to the left of 3, I got a negative number. Let's do the same as x is approaching 3 from the right. I'm going to think about the number just to the right of 3, like 3.001. Plugging that into the numerator and adding 2, I get a positive number. plugging this number into the denominator and subtracting 3, I also get a positive number. So this one must be positive infinity as x approaches 3 from the right. Let's take a look at the graph of this rational function to see if this matches up. Now we said as x approaches 3 from the left-hand side, our value we got was negative infinity. You can see that right here. And as we approach 3 from the right, we got positive infinity, and you can see that right there on the graph here. Now, because those values are not equal, because from the left we get negative infinity and from the right we get positive infinity, I'm going to go all the way back to our original problem and say our answer to this limit does not exist because those limits are not equal. But once again, we couldn't determine that just by direct substitution, and we had to look a little bit more closely and look from the left-hand side and look from the right-hand side to see specifically what was going on. Another reminder I wanted to give is that a limit that has a value of infinity or negative infinity is different than the limit as x approaches infinity or negative infinity. This one, where the limit is equal to infinity or negative infinity, deals with a vertical asymptote, whereas the limit as x approaches infinity or negative infinity deals with the end behavior of a function. If you'd like to see a video on that as x approaches infinity or negative infinity, click here to see a video that I made about end behavior. I hope you found this video useful in finding the limit as x approaches a vertical asymptote. Now, sometimes you may have to factor a problem first to kind of get it to this simplified form. So just as a note, that sometimes may happen. If you did find this video useful, make sure to give it a thumbs up and subscribe so that you can see more calculus videos by me in the future. Thank you so much for watching.